In this video, we're going to see how to solve a standard first-order linear differential equation. So I've written here the base form is x prime of t plus a times x of t equals f of t. Now for us, that a is always going to be a constant number, so it'll make it easier, but you could possibly have things more generally for a there, as you'll see in like a math class in differential equations. Similarly, that f of t here, that right side of the equation, for us is just going to be a constant right now. We will see some things where it's not constant in the future, but for this point in time, even the non-homogeneous f of t is going to be a constant number. Now when we're going to solve an equation like this, we first solve the homogeneous version. And how you make it homogeneous is you make it equal to 0 there. So then we're going to go ahead and move this to the other side. X prime is dx dt here. We get all the x's on one side and the dt on the other side. Then we're going to go ahead and integrate here. 1 over x dx is going to be ln x equals negative at plus c. Sure, you would put a plus c for each integral, but you could then subtract the constant from one side to the other, and some random constant minus some other random constant is just a different random constant. Then finally, to solve for x, we raise e to both sides here. Now e to two things added, you can make it e to the first thing times e to the second. And e to some number is just going to be some other number. So we usually write this as the following here. X of t is equal to some constant, e to the negative at. That's our homogeneous solution for these. Now, for a particular solution, this would depend on what exactly your right side is going to be. In this case, though, we're going to go ahead and assume the right side is just a number. And so whenever you have the right-hand side being a constant, you are going to guess for your particular solution, yx here, particular x is going to be some other constant. We'll call it, d. And we're going to plug it in the equation. So if that's the case, the derivative of that is 0. So I would have 0 plus a times d equals b. So my particular solution then is going to be the constant b over a. And your final solution, which includes everything, is going to be b over a plus c e to the minus at. And we're just going to go ahead and change the letters that we're using here and just write this as some constant k1 plus some other constant k2 e to the negative t over tau. So the little a that was in the original equation is going to be 1 over tau here. And tau is what we're going to call the time constant. And I'll have a separate video trying to explain what time constant means here. But at the end of the day, from now on, you should just know that when you're trying to solve an equation like this, we're just going to skip straight to the answer. It's going to look like this type of answer here. And then instead of actually doing the calculus, your job is going to be just to figure out what those k1, k2, and tau are for the given problem. And then you'll have your answer. So this is a brief overview of solving basic first-order linear differential equations. But from now on, we're always going to skip straight to this as our standard answer.